And with that, I'm going to give you some background on our wonderful speaker. This is really kind of a personal hero of mine. I reached out to him before I even came to Port Townsend because I was so interested in the work that he's been doing and just really wanted to kind of find out how I could support everything that he does. So he's going to tell you more about what he does today. But so Dr. Hodum is a biology professor and the director of environmental policy and decision making at the University of Puget Sound down in Tacoma. There he teaches a variety of courses in biology and environmental policy programs. Here in the Pacific Northwest, Dr. Hodum studies ecology, population dynamics, and conservation status of burrowing seabirds, particularly the Rhinoceros Auklets and the Tufted Puffins. He collaborates with the Slater Museum of Natural History to study the effects of marine plastic debris on marine food webs. He has his bachelor's degree from, I forgot to ask how to pronounce this, Bowdoin College in Brunswick, Maine, and he earned his PhD from UC Berkeley. He also co-founded and leads a long-term community-based conservation program in Chile. He is the director of the Chile programs for Oikonos, a nonprofit that leads conservation projects in Chile, California, the North Pacific, New Zealand, Mexico, and Antarctica. So he does a lot for these birds, and we appreciate him. So without further ado, please join me in giving Dr. Peter Hodum a big Port Townsend welcome.
Thank you so much for that wonderful introduction, Bea. I'm honored to be here. Thank you to the Port Townsend Marine Science Center for the invitation to be here with all of you this afternoon. Thank you all for coming out and dedicating some of these precious hours of sunshine, late autumnal sunshine. I appreciate it. So I want to just start broadly by saying that I've been thinking about seabirds for decades. I had a formative experience as an undergraduate, not on this species, but I put this image up for a couple of reasons. One, it's a species that we've been working on in Chile for a couple of decades now, the pink-footed shearwater. But more than the species and its status, this picture for me captures why I've fallen in love with seabirds, or why I fell in love with seabirds nearly 40 years ago now as an undergraduate. The grace, the beauty, the mystery, you know, the way they live their lives in a part of the world that we just struggle to imagine how you could do it. Covering scales of distance that are, again, virtually unimaginable to us. This is a bird that breeds in Chile and it migrates up, you know, in the summer months here, we can see this species on the outer coast of Washington. And then it goes back to breed again the next season. So they operate on these scales over decades. And so much of that mystery and the grace of seeing a bird like a pink-footed shearwater in flight is what really, more than the science initially, drew me to them. And they've never let me go, which I'm very thankful for. As Bea mentioned, a lot of my work over the last 20 or so years has been in Chile. Focused on conserving threatened and endangered species on multiple islands. And it wasn't until I moved up here to Washington in 2004, 2005, that I had the opportunity to really begin to explore this region and the opportunities and the challenges facing seabirds up here. And I was incredibly fortunate that my first seabird research experience here in Washington was out on Tatoosh Island, which is the property of the Makah Nation. And we were able to work out there for a number of years on tufted puffins and rhinoceros auklets. So that was my entree into seabird experiences here. And during that time, I met some colleagues and we've developed what's become a long-term conservation program focused on seabirds here in Washington. So I wanted to just give you a sense of how I'm structuring the talk today. And just one thing I wanna, here we go. And I'm going to start with just a quick overview of the islands of the outer coast and the Salish Sea, just to give you a frame of reference for the scale, again, of the opportunities and the challenges for seabirds in this region. And then talk a little bit about the status of seabirds in those two regions. Then narrow it down to a few focal species that kind of, I think, illustrate some of the challenges and opportunities that seabirds in our region face. And talk a little bit about the threats, and then looking forward, where are these opportunities to actually move seabird conservation and forward? And if you can move seabird conservation forward, you're moving other conservation forward, including conservation of island ecosystems, conservation of inshore marine systems, etc. Oh, whoops, sorry. So I wanted to jump into the islands to say that we take our research seriously, and we are willing to risk life and limb. We cross treaty lines, vampires, werewolves. We have to deal with it all out there. For those of you that don't know what I'm talking about, like, what is that? There was a phenomenon about 10 years ago. It was a teen novel series called Twilight that was set in Forks. With vampires and werewolves. And there are still, this is out on the way to La Push. There's still signs out there of this rivalry. They marketed it up as they took full advantage of that while the phenomenon is existing. But we go out of La Push frequently for the outer coast work. And the outer coast of Washington is one of the most stunning coastal systems that I have ever seen anywhere. They're remarkable islands. They're not large, but they're rugged, and they just seem to defy the ocean. They just seem to defy the weather and the climate and the time. And you get these spectacular islands that are really difficult to access. I mean, imagine trying to land, notice the conditions here. Those are not necessarily common conditions. We tend to take pictures when, your boat's not getting spray over the top of it. But they're difficult to access. Conditions can be really challenging. And another piece of it is, and this is actually a good thing, but these islands, almost all of the islands on the outer coast of Washington are National Wildlife Refuge islands. So they're very tightly managed by the federal government. They're closed public access. They're restricted research access. So there are a number of factors that have contributed to the fact that we don't necessarily know a lot about these islands. Yeah, good luck getting up that one to find out what's on top. And then, once we move into the Salish Sea, we have islands that have less relief. They're easier to access, including Protection Island here, which is a familiar sight to many of you, I imagine. Stunning island. And this is also federally protected, as well as having a part of it that's state land that's protected. So I recognize, and I think it's probably quite healthy to say that most of you have not spent as much of your life thinking about seabirds as I have. So I wanted to give a quick primer to just a few aspects of their life history, because understanding some of the things about how seabirds make a living is really important to understanding why the threats that confront them are so impactful. So seabirds are quite a broad group of birds, ranging from species that are inshore, like pigeon guillemots that you can see, foraging within a few meters of water, to birds that basically spend their entire lives in the open ocean, hundreds of miles from shore, except when they come back to breed on a remote island somewhere. So incredible range of use of ocean habitats. Literally everywhere in the ocean is utilized by some seabird species or another. They're really long-lived, so they have high adult survival. And that can range from 15 to 20 years for some of the shorter-lived species, up to albatross species, which have been documented living over 70 years. And not only that, they continue breeding. So some of you may be aware of Wisdom, the Laysan albatross out on Midway Island. She is over 70 years old now, and just last year she raised yet another chick. So incredibly long-lived. associated with that, and all of this is tied into thinking about how do seabirds live in a really challenging environment. They live, they spend most of their lives, if not virtually all of their lives, on the ocean, finding food that is mobile, that can be unpredictable in space and time. So it's not an easy life, and they may need to travel huge distances to access food. So a lot of this is tied into that, that selection has favored them. It favored adaptations such as deferred sexual maturity. It takes them a number of years to reach the point at which they begin breeding. And that's essentially, if you think about it, it's giving them the chance to develop the skills to take care not just of themselves, but also offspring, because that's an additional demand, as those of you who are parents will know. They also have a low reproductive rate. Many seabird species lay only one egg a year, maybe two. Some will go up to 3 or so. And in many of those species, that's it. If they lose that egg, if they lose that chick, that's it for the breeding season, for the year. They can't replace the egg because they invest so much energy, so many resources into the formation of that egg. Females can't come back into condition well enough to replace anything that's lost. So very low reproductive rates. Most species are migratory, and that migration may be a few hundred kilometers. It might be tens of thousands of kilometers between breeding seasons. So things like sooty shearwaters that breed in New Zealand, they migrate up the west side of the Pacific, off the Japanese islands, around to Alaska, and then from Alaska move down the west coast of North America before they make a diagonal all the way back to New Zealand. 40,000+ kilometers in a few months between breeding seasons. So all of this is, if you put it all together, it's a very complex life history. Many of these species cover vast spatial scales across many, sometimes ocean basins, hemispheres, certainly governmental jurisdictions. And then they live a long time, they have low reproductive rates. All of this ties into a scenario which has really important implications for conservation. So what do we know about seabirds and seabird conservation in Washington? In the Salish Sea, we have about 73 species, which are either highly dependent on Salish Sea waters seasonally or year-round. So as a lot of you may know, we actually have greater species diversity in the Salish Sea of marine birds during the fall, winter, spring months, where you get things like sea ducks that breed on freshwater. They come out and will spend the winter months, in loons and grebes that come out to salt water for the winter. And then they go back into interior breeding areas from here up into the subarctic and low Arctic. So a remarkable number just in the Salish Sea that really rely heavily on our waters. On the outer coast, we have over 50 species seasonally. Many of those are actually migrants that come into the system from the southern hemisphere. So they're basically escaping the southern hemisphere winter to come up here. So it's almost like they're an endless summer. And then they clear out again they're gone, largely gone by now from our waters. So if you kind of add those together, there's certainly some overlap between species, but you have a pretty significant diversity of marine birds in Washington waters when you look holistically across the Salish Sea and the outer coast. Of those species, we have 2 species that are currently legally listed at the state and or federal level. So marbled murrelet, and I'll talk more about these in a little bit. Marbled murrelet, which is both federally and state listed, and then the tufted puffin, which is state listed as endangered and a federal candidate. And I'll come back to those in a minute. I also wanted to just give you a graphical representation of what does that diversity look like in terms of different families of birds, and I'll walk you through this. So on the left column, right there, is the family of seabirds. So storm-petrels are a family of seabirds, petrels and shearwaters. Alcids are the family that is puffins and murres and guillemots. Cormorants, and then gulls and terns. this is the number of species right here. And then, note, is that the, we'll get there in a moment. This abbreviation is the number of species in that family that are vulnerable or endangered. And these are the 4 species, the 4-letter species codes. So Leach Storm-Petrel, fork-tailed Storm-Petrel. So I've put in orange the ones, the distribution of the threatened and endangered species. I do want to note that Leach Storm-Petrels, although officially they have not been declared as an endangered or threatened species at the state or federal level, we consider them biologically to be threatened because of the population declines that with the limited data that exist. So it's something that we're increasingly paying attention to. But it's interesting. You'd think for a group of birds, it's fairly visible, you know, in Washington waters, we've got state agencies, we've got universities, we've got federal agencies that we might actually know with a great degree of certainty what our seabird community looks like. But if you look at the number of species, there's a couple of question marks, and that's just an acknowledgement that it truly is a mess. Gulls have no shame. They will interbreed quite happily with each other. And so there's all sorts of hybrid combinations that we get. But the question marks are actually really exciting. And I'll give you an example of how we're using some technology to try to get at these questions. But that's a Manx shearwater. The Manx shearwaters are known to breed only in the North Atlantic. Northeast Atlantic around the UK, as well as in the Northwest Atlantic. But we regularly see small numbers of Manx shearwaters in Washington waters during the summer months. They could be birds that are just terribly geographically confused, and they went up the wrong side of the Americas because they migrate down into South Atlantic waters during the northern winter. So it's possible that they just got the wrong side of Tierra del Fuego. I'm like, this doesn't look right. The coast shouldn't be over there, but oh well, we'll just keep going. It's also possible that they're breeding up here in small numbers. It's something that's of considerable interest to us. The other question mark here, ancient merlets. There's one kind of semi-credible record of an egg being found that was attributed to an ancient merlet on one of the offshore islands 95 years ago. Since then, there's been nothing. But there's a lot of evidence indirectly because we see adults with young chicks on the outer coast. And it's really impossible to reconcile that with any other conclusion that they're breeding out here and they've just never really been documented. But with breeding seabirds, especially burrow nesting, nocturnally active seabirds, it can be really hard to figure out who is where on these remote islands. So what we wind up with, if we kind of look across species, for many species, we really don't understand well the status and trends of a lot of those species, even today. And that's an exciting opportunity, but it also presents a real challenge if we're trying to establish conservation priorities. We don't know enough to know which species are really in trouble or declining. So I'm just going to run through a few species quickly to give you a sense. This is not exhaustive. We'd be here most of the afternoon if I went through all of the species we see regularly, but just a few that are common and are species that we're trying to get a better understanding of some of the trends. So Tufted Puffin, as I mentioned earlier, state listed as endangered, federal candidate for listing under the Endangered Species Act. And there are now a couple of documents from the state of Washington. This was essentially a conservation status report, and that was the basis for the endangered listing 7 years ago. And we recently came out with a Tufted Puffin recovery plan that was 3 years ago. Rhinoceros Auklets, which are actually a puffin, although the common name is auklet, they are a puffin. And we've used them as, they're essentially a sister species to tufted puffins. And so they have a very different story, which is an interesting comparison and contrast. They co-occur on many islands, and yet tufted puffins are declining precipitously, as I'll talk as one of our case studies, while Rhinoceros auklets seem to be thriving. They seem to be accommodating whatever changes they're experiencing out in the marine environment. They seem to be accommodating them just fine. And we actually have some evidence that the population on Protection Island has actually increased since the 1970s. Leach's Storm-Petrels. And this is the bird that got me hooked on seabirds as an undergraduate. Leach's Storm-Petrels, these incredible small birds. They're this big. They weigh 1.5 ounces. They can live over 40 years, and they spend 90+% of that time in the open ocean, sometimes hundreds of miles from shore. If you think about winter storms, hurricane force winds, and these birds thrive in those conditions. It's really difficult to kind of wrap my head around that. And they're just so graceful in flight too, beautiful birds. Cassin's auklets, this is a species that is a species of conservation concern. It's currently, we kind of classify it as near threatened. This is also in that alcid family. So along with the puffins and the murres and the guillemots. Marbled murrelet, I wish this were my photo. It's a stunning photo. I have no idea how many photos I've wasted trying to get a decent photo of a marble murrelet. Full credit to Glenn Bartley. This is a stunning one, but Washington endangered and federally listed as threatened. Manx shearwaters, 2 here in a flock of sooty shearwaters on the outer coast. We took this a few years ago. Again, we regularly see them in small numbers around north of Destruction Island and up through kind of that middle part of the outer Washington coast. It doesn't mean that they're breeding, but we see them every year now in small numbers. So it is possible that there's a critical mass of birds, that there is a small breeding population. But again, they're a burrow nesting seabird that visits the island, their breeding islands at night. It's really hard to get a handle on, especially when you think about where some of those islands are and the topography of them. How do you actually even begin to assess whether they're there or not? Ancient murrelet, I mentioned this is another one that we're trying to confirm breeding. A beautiful little seabird. Again, this is in the same family as puffins and guillemots and auklets. So one of the islands that we work on is Alexander Island. This is, it looks inaccessible from this perspective, but there are some, with good conditions, you can actually land on it and get up onto the island. It is pretty fragile. And so we do try to we limit our time on the island. I did want to say that the work that I'm talking about is not my work. This is highly collaborative work with a number of colleagues. In this photo on the far left, this is my colleague Scott Pearson, who's a senior research scientist at Washington Department of Fish and Wildlife. I do get to bring a lot of my research students on these projects. So this is a student from a couple of years ago, Lily. Tom Good is a research scientist with NOAA, Northwest Fisheries Science Center in Seattle. Sue Thomas is the refuge biologist for Fish and Wildlife Service for the entire refuge complex. To talk about a ridiculously huge job. She is the refuge biologist for a refuge complex that has 40+ islands. I don't even know how many islands it is. And then in the back is Chad Norse, who's a biologist and the boat captain for Scott's research team. Spectacular island. This is Alexander looking to the south. There's Destruction Island on the horizon. This is beautiful habitat for burrowing seabirds. Incredible density of burrows on these slopes. Like in this photo, if you were to count, there would be well over 1,000 burrows just in this vegetational arc. It's beautiful habitat, and there are no non-native mammals on the island. It's a well-conserved island, and it is a fantastic seabird population. But again, we're not fully sure exactly what the full community of seabirds looks like. So it's something that we're working on. And one of the ways we can do this is to use for these islands that are difficult to access or where it's inappropriate for us to spend much time, where we try to have a really, really light footprint. So an island like Alexander, this island here is Jagged Island. This is very, very friable, shallow soil. It's not a place that would tolerate humans moving around on it much. You'd cause a lot of damage. We can use technology to our advantage. And I think this is really cool technology. These are basically high-tech tape recorders, but they're programmable, so you can get them to record at whatever intervals you want. So it's called bioacoustic monitoring. All you're doing is recording ambient sound. And then you can use algorithms, so computer programs developed by people far more clever than I, to sample whatever you've recorded, hundreds or thousands of hours, and they can pick up the acoustic signature of individual species. So you can basically teach it, this is what a tufted puffin sounds like. This is what a Leach's Storm-Petrel sounds like. And then it will go through and it will identify those. And so we've been using, and you can deploy them. You go onto the island, deploy a handful of them, come back at the end of the breeding season, retrieve them. So you're on and off the island, no damage done. And then you actually get different metrics, different types of information about what's there, in what sort of abundance are they there. And an example of this, which is really exciting for us, is from the Bedelta Islands. So the Bedeltas are, if you look at this map, the little red square in the inset gives you, so here's Cape Flattery up here. So kind of central northern outer coast. They're very inshore. You can almost walk to the innermost one. And we were particularly interested in these islands for storm-petrels and the possibility of ancient merlets. And this is a sonogram. Here's frequency, and here's the time. So this is what the vocalizations look like if you graph it, if you graph the frequency by time. And that little box right there in the yellow, I'm sure you all recognize that, right? Yeah, that's actually an ancient merlet. And it was picked out by, basically this artificial intelligence. And so this tells us that there were ancient merlets on the island, because there's no way we would have been able to get any vocalizations from sea. They don't have that sort of a range. So this is an island with ancient merlets on the island, which doesn't prove categorically that they're breeding there, but this is a species that really only comes ashore if they're breeding or certainly trying to breed. So the next step is to try to actually figure out if they are there and in what numbers, but really exciting. And we're using this sort of technology again on multiple islands where it's just inappropriate to be there for multiple days working kind of more intensively. Which is what we actually are able to do on Destruction Island. So Destruction Island is a little bit more amenable to that sort of work. We have a long-term conservation research program there focused on multiple species, including Rhinoceros Auklets and Tufted Puffins. There's a Rhinoceros Auklet bringing back some fish for its chick. And then it's a spectacular island with a really nice community of seabirds, including Brandt's cormorants, the ubiquitous pigeon guillemots, which just seem to thrive everywhere. They do really well down in Olympia. They do well off Seattle. They do well out here. They do well on the outer coast. And they're just such charismatic birds too. So Protection Island is an island that we've been working on now for 15 years. Primarily on Rhinoceros Auklets and Tufted Puffins. There is a large gull colony there. There are cormorants, etc. But our focus has been on those two alcids. Similarly on Smith Island. So Smith Island is up off the northwest coast of Whidbey, not that far from like Deception Pass. So I'm going to switch now to give a few case studies, the first of which is Tufted Puffins. Yep, that's one of my little plushies that goes with us as a good luck charm. It's not my daughter's. I can't even say it's my daughter's, it's mine. And I'm okay with that. But tufted puffins are a species that, I think it's easy for such a charismatic species to think that we would know a ton about them. And thanks, in fact, to work by John Pyatt. Some of you may know John Pyatt. He's been based in Port Townsend for a number of years. He's done an amazing amount of work with seabirds up in Alaska, including tufted puffins. So we actually have a good sense of how tufted puffins are doing in Alaska. We know a fair bit, thanks to Canadian Wildlife Service, about how they're doing in British Columbia. But Washington, Oregon, and most of California, we really don't know that much, about a species as charismatic. Who doesn't love puffins, right? Who doesn't think they're really cool, if a little bit bizarre looking? And yet we really don't know much about them in this region. So what we do know is that historically, these are based on records from early naturalists, our best, going through all of the literature that we could find, that there were 43 active breeding colonies. So we consider those to be islands. So 43 islands in Washington waters that had active breeding colonies of tufted puffins, ranging from a handful of pairs up to thousands of pairs, depending on the island. By 1978 to 84, we used that as another kind of window to compare. We'd lost a handful of those islands, largely the islands that were smaller. So they had smaller populations, much more vulnerable to disappearing. But we still had most of the islands. Then you look at that last number. So in the last 30 to 40 years, we've lost another 50%. So now we're down below 50% of historically occupied islands still have puffins breeding on them. That's really worrying. If we look at colony size, it's a similar pattern where we see prior to 1978, we had 9 colonies where the estimates were greater than 1,000 puffins associated with them, and 2 with estimates that exceeded 10,000 puffins. Our most recent boat-based surveys now, we don't have a single colony in the state that even has 1,000 birds associated with it. And we only have 3 that have as many as 100 to 200 birds. We're talking about orders of magnitude decline, largely, we think, within the last 40 or so years. There was a suggestion of a decline, slow, but a decline up to the late 70s, early 80s. But since then, the population has really fallen off a cliff. If we look at this figure, so this is a figure, there's two panels here. So the upper set, the A, B, and C, these are all outer coast, and you'll see the time. So the late 1800s through the 1970s is the leftmost panel, 1978 to 1984, and then 2007 to 2010. And the color and the size of the circles correspond to colonies and their relative size. So the bigger colonies and the purple, orange were the larger colonies. And what you can see if you look across those 3 is a reduction in numbers of colonies and the gradual decline in size from what we know from a century or so ago. And then the bottom set of panels, D, E, and F, same time periods, but this is for Salish Sea islands that have historically had puffins. So again, late 1800s to the mid 1970s, late 1970s to early 80s, and then most recently. So, what the take-home story for the Salish Sea is that we never had huge, well, I shouldn't say never, within the last 100 or so, 100+ years, we didn't have huge colonies. But we did have a number of smaller colonies scattered widely throughout the San Juans, including some that had hundreds of birds associated with them. And we're down to 2 islands now, Smith Island and Protection Island. And I'll come back to them in a moment. So if we look at what this suggests to us, is that our estimate, using some very limited data, so this is a crude estimate, but nearly 9% annual decline. even if you give it a little bit of error around it, say 7 to 10 or 11%, a species like tufted puffins, with the life history that they have, slow reproduction, when they're long-lived, high adult survival, single egg they lay every year, they can't replace it if it's lost. Even under the most ideal conditions, they're incapable of recovering a population quickly. And those sorts of what we call life history strategies are particularly impacted by changes in adult survival. And that's what we seem to be seeing here. So on the outer coast, and again, please take these numbers with not just a grain of salt, it would be a bowl full of salt. There's a lot of error likely associated with them, especially the earlier estimates. But even if you're off by a few thousand birds, the take-home story is that we've probably lost about 90% of puffins on the outer coast over the last century. And again, most of that is presumably over the last 40 to 50 years. If we look regionally with what we call the California current, the large marine ecosystem, so that California current that flows from Vancouver Island down through Washington, Oregon, and California, we actually see similar patterns. So Oregon, there's been a 90+% decline since the 1980s. That aligns really well with what we're seeing here. And in California, since the early 1900s, they've also seen a decline of upwards of 90%. So what's happening here is actually symptomatic of what's happening on a larger scale. So some of the work that, I'm not going to get into the details of the work that we're doing, but I wanted to give you a sense of some of the approaches that we're taking to try to understand what's going on with the birds. It's one thing to document the declines, but as a conservation biologist, we don't want to just document something until it goes extinct. It's to do the research that informs the conservation interventions. But to do that, we need to understand why they're declining. What are the drivers? So we look at things like provisioning rates and breeding success. How are they actually faring? Are they producing chicks? Are those chicks fledging successfully? We look at numbers of birds associated with the colony as a metric of the larger population of size associated with an island. And then we look at diet. So changes in diet has been one of the factors that has been suggested as a potential driver of decline. Because if we think about diet, it can be affecting them in different ways. The same fish might be present, but if they're in different places, if they're inaccessible, then you can't access them. And the birds, so there's a question of abundance and there's a question of accessibility. And trying to tease that apart can be really challenging. So coming back to what we have here in the Salish Sea, just to give you some numbers, and it should always worry you when a conservation biologist comes up and gives you a precise number, like 25, that's not good. You want to hear things like about, approximately, 4,000 or 4,200. But on Smith Island, 25 breeding pairs the last couple of years, 24 last year, 25 this year. And on Protection Island, there's so few that we're not sure, because the amount of effort it takes to actually find the birds and then track them into a burrow and confirm that they're breeding is, we just don't have the resources to do that. We're confident that today there's less than 5 breeding pairs on the island. And in the 15 years that we've been working out there, just looking at where the birds raft up offshore of the island, which is typically off the southwest side, we've gone from seeing 7 to 8 birds in the mornings during the breeding season to right now, like this past summer, I never saw more than 2. So I think this is a population that, at least in the short term, is on the cusp of blinking out. So if we look at puffins and think about Rhinoceros auklets as a puffin, we can do this comparison because we've been doing similar sorts of work on both species. And recognizing that the Rhinoceros Auklet seem to be doing fine, it can help us tease out a little bit, what might be causing this, because they're both burrow nesting seabirds, they're breeding on these same islands, and yet the Rhinoceros Auklet population on those islands is doing fine. Tufted puffins obviously isn't. So we can look at population size. Rhinoceros auklets, again, at least in the Salish Sea, our evidence suggests that they're actually been increasing over the last 40 years. Whereas, as you're now familiar with, that's certainly not the case with tufted puffins. With reproductive success seems to be higher again for Rhinoceros auklets. And although we only have indirect measures, those measures suggest that tufted puffins have actually decreased in their reproductive success rates. And diet, we do have some really nice data from both the outer coast and Protection Island on diet from the 1970s for Rhinoceros auklets. Their diet hasn't changed over the last 40 plus years in terms of the composition, the species you find. We don't have historical data on diet for tufted puffins. We're kind of trying to craft that in different ways. So looking at current diet we can do, and we're also using techniques like stable isotope analyses to use museum specimens to basically do historic diet. I'm not going to get into the details of that. The take-home message from that is that there is no evidence that for tufted puffins, their diet has changed trophically, or if you think about the level in the food web they're foraging, over the last 100 years, it's stayed stable. But that doesn't mean it's as abundant and as accessible. So they might be eating the same thing, but they just can't find enough of it to consistently do well. So last little case study is one which I think is kind of an inspiring one. So marbled murrelets are a small alcid. They, again, are federally listed and state listed. And I'm just going to transition to this slide because these birds are wacky. That's the highly technical scientific classification for them, but they do something that by most standards would be considered pretty bizarre. If you were to think about where you would expect to find seabirds breeding, most of you, to the degree you've ever even entertained that question, would probably say, oh, along the shore, maybe on an island or on a headland, something like that. These birds say, nah, that's passé. We are going to breed in old growth forest, sometimes dozens of kilometers inland, way up in the canopy on the branches of large mature trees. So here's an illustration, nice little chick on an old growth tree. The egg is laid on the branch. It hatches. Parents bring fish in, feed it, and it eventually goes to sea. The complication for them is, as you all know, old growth forests are not nearly as abundant as they were historically. This is true from California up through Oregon into Washington. And so throughout their lower 48 range, marbled murrelets have declined significantly. A lot of that is attributed to the loss of breeding habitat with our destruction of old growth forests. But they do persist, and they persist in the Salish Sea. They persist on the outer coast of Washington. And they're actually quite well studied. So Scott Pearson for the state has worked with the federal government for a number of years monitoring the populations at sea. There's been some work, breeding season work done on, they don't really nest in colonies. They nest individually in trees. But if it weren't hard enough, if it weren't challenging enough already, these birds also, for predator avoidance, come and go at night. So imagine trying to find, a nest that might be 100 plus feet up in a tree, for a bird that's this big, that's flying in at night at 40 to 50 miles an hour. How do we find those nests? How do you find where those birds are? And through tracking, capturing birds and putting transmitters on them, there's a lot has been discovered. But this leads me to talk a little bit about an area where we basically have completely discounted for marbled murrelets, and that's the South Sound. And this is a project that I've been doing with my students for the last few years, where, so I'm a really keen sea kayaker, and every opportunity I can, I get out onto the water. And a number of years ago, I started noticing during the breeding season, these spots where it's like, it seems like every time that I paddle past these areas during the breeding season, I see, you know, one or a few or a handful of marbled murrelets, and they're in breeding plumage. But I didn't really quantify it. And I'm like, this could be interesting. So I talked with my colleague Scott and asked, you know, have your surveys picked up these areas? And he said no. So they survey pretty intensively, but because of this, the scale of the surveys, it's not like they can spend a lot of time in any one area. So if you think about, you know, 1 to 7 or 8 marbled murrelets in a spot, and a boat going past there twice a season, you know, at 8 to 10 knots, it's quite possible that those birds are underwater or they just weren't there in that moment. And so they hadn't picked these areas up. So over the last couple of years, several of my students and I have started to look at these areas, and these little orange ovals are areas, and then there's the blue one down here. These are areas right around Tacoma. So this is Commencement Bay, just to orient you, Point Defiance out here. Here's the Narrows Bridge, just to give you a frame of reference. And we've actually confirmed that these are areas that over the last 3 seasons are consistently used by small numbers of marbled murrelets, which is potentially really interesting because they're only there during the breeding season, and all of the birds there are in breeding plumage. So what it suggests is that there might be a remnant population of marbled murrelets still breeding in the South Sound, which has not been documented previously. So that's kind of the next step, but that's a big next step because they could be going, we have no idea. You know, if you look at where old growth is in that area, it's very patchy. There's nothing anywhere near the inshore. I mean, they could be going up towards Mount Rainier or Federation Forest State Park. But again, you have a little missile that's traveling at 40 miles an hour at 2 in the morning. Not the easiest thing to track down. But it is exciting. And I think for me, it's also this symbol of hope. You know, here's this endangered seabird that is still persisting, you know, in a really urbanized environment. They're still there. They keep coming back. They're foraging successfully, hopefully, and we have seen some fledglings both summers. So again, it's strong suggestion that they are breeding, and at least some of them are breeding successfully in an area where you're like, what are they doing down there? Whatever they're doing, they seem to be doing okay. So there's Browns Point Lighthouse. So this is the area that has the most birds and most consistently. So you want, I mean, you can see marbled murrelets off Point Wilson or off Fort Flagler, but if you're ever down around Tacoma, a great spot, not just for during the breeding season, but a great spot to do some sea watching is Browns Point Lighthouse right here. And it's a really cool lighthouse. It's one of the few remaining Art Deco lighthouses in the United States. Really quickly, I just wanted to talk a little bit about threats to seabirds. I'm in Washington waters. And these are kind of global threats. So you could remove Washington waters and say these are general threats confronting seabirds globally. Not all of them apply to all species, but a lot of them are things that we at least go to as a list, like, okay, which ones of these might be likely contributors to declines in seabirds? The first is declining prey availability. You know, what we do know about forage fish in our waters is that populations have changed. Some naturally, some because of changes in environmental conditions. So if we think about forage fish like herring, anchovy, sand lance, smelt, things like that, those populations have changed. And some of you may be familiar with the collapse of Pacific herring, or effectively, throughout most of the Salish Sea region. That has implications for things that feed on them. Recovery of avian predators, and this is a complicated one, because we're not saying that it's not a wonderful story to see bald eagles. Like, how many of you get excited, like just show of hands, how many of you like remark like, oh my gosh, there's a bald eagle when you see one these days? I'm impressed. A lot of people are like, yeah, bald eagle, and then you keep going because it's wonderful. We see them now I'm sure you see them every day here. I see them every day in Tacoma. That wasn't the case 40 or 50 years ago. We nearly lost them, at least regionally. So it's a remarkable recovery story. But they're recovering into a system that is very different than the system that they disappeared from. We look at these birds would have eaten heavily on salmon populations 50, 70, 100 years ago. Well, salmon populations are not faring so well. I know that's a secret. Don't tell anyone. But if you remove, and they're flexible predators. So if you remove kind of what they traditionally have eaten, they can shift really easily because they're opportunistic. So bald eagles now are spending a lot more of their time in seabird colonies. So, it comes down to what happens when your endangered species eats my endangered species. Who wins that? So it's an interesting ecological story, but I think it highlights some of the complexity of the decision-making that needs to go in to really informed conservation planning. Contaminants and pollution, these are both acute, like oil spill events versus chronic, things like these stable, persistent organic pollutants that are in our waters that will be there for decades and decades. So chronic kind of ongoing exposure, which they can get through their food, as well as acute events like spills. Fisheries bycatch, this is certainly one that we suspect strongly with the declines in tufted puffins. Historically, not so much recently, but gillnet fisheries, until those nets were modified about 15 or 20 years ago, had really high levels of seabird bycatch. And we do know that puffins were caught in those in pretty large numbers at times. Shoreline armoring. This is one that's not a direct factor, but in areas like around Port Townsend, where you have feeder bluffs and you have all that sediment that, quote unquote, wants to flush into the inshore system, that brings nutrients and all sorts of resources that feeds that inshore system, creates really productive conditions for small fish and basically the base of the food web. If you interrupt that by hardening or armoring the shoreline, you're eventually starving those inshore waters. So that has implications for eelgrass beds. It can have implications for kelp, etc. And that then magnifies up. So that then has consequences for the things that forage fish eat. And that then affects forage fish, which ultimately ripples upward and affects upper level predators like seabirds. Introduced species, both plants and animals. This is a photo from Destruction Island. European rabbits were introduced by bored lighthouse keepers in the 1970s. It's a stare down, but given how timid puffins are, rabbits generally win. So introduced species can be a problem, both animals and plants, if plants are changing habitat conditions. Disturbance is one that, because most of our breeding islands in Washington are actually already federally and/or state protected, on colony is usually not much of an issue, but at sea it can be. For some species, it can be a consideration. Harmful algal blooms, we're starting to see increased frequency of those, which is tied to climate change. I don't need to spend a lot of time talking about climate change, I don't think, to this group, but climate change does drive changes in environmental conditions, including ocean productivity, etc., which has implications for seabirds. And then related to that is ocean acidification, which isn't a direct factor on seabirds, but it can affect prey or secondary prey for seabirds that that are vulnerable to the acidification. Those that have calcareous shells, like krill and so forth. So I wanted to, although this is a talk primarily about seabirds, I wanted to leave really with, or finish this part with just a couple of comments about forage fish and ecological connectedness. This figure in the upper left is one that I find really compelling in its simplicity and how much it captures. Is really well done by Pew Environment Group. So if we think about energy flow moving upward vertically in the figure, down at the lower, so if you think about this as a food web, very simplified food web, plankton down here, both phytoplankton and zooplankton, which is the basis of food for forage fish. You see that's kind of like this wasp-waisted or this hourglass figure. That's the constraint. As in our systems around here, this is the limiting factor. If this level trophically is doing well, everything above it will do well, either directly or indirectly, because everything above forage fish, they're either feeding directly on forage fish or they're feeding on the things that feed on forage fish. So forage fish are absolutely critical part of our food webs. And we can look at this in this figure here, which I don't know if not sure if you can read this from the back. If not, I apologize, but I'll talk you through it. The left side is a very, very simplified food web for our region with forage fish centered. For those of you who can see it well enough, you'll see that some of these groups, functional groups, are bolded. Those are considered to be historically dominant groups that help structure the system. So you can see forage fish is bold, rockfish, salmon, seabirds, historically. On the right side is more representative of what we see today. So nothing has disappeared. But there's the forage fish right in the center, forage fish here on the right. They're no longer bolded. It's not like they're not there, but for many of those species for which we have good information, they're not nearly as abundant. So they don't play as significant a role in the system. And when that changes, it has implications for seabirds, which are no longer bolded, salmon, and rockfish. And what we see is other functional groups adjusting to that and thriving. So we see things, opportunistic groups like ratfish, Dungeness crabs, and jellies increasing in number. So the system changes in response to the conditions. So looking towards the future, I'm a scientist, right? So I'm like, oh yeah, got to talk about more research. And to a point, it is necessary. There's still a lot, as you can infer from the information that I talked about, we don't have. So we still are trying to understand better population trends for many of the species of conservation concern. And then understanding which threats are the most important ones. It's one thing to say a species is declining and it could be 5 things, but of those 5 things, you probably can't address all of them meaningfully. Are there ones that you're confident actually are having a disproportionate impact? Those are the ones you want to target, if possible. Following their breeding seasons, again, which is part of the trend assessment. And then understanding how they're using marine habitats, like the marbled murrelets. That's it down in the South Sound. Those are small areas, but that's critical habitat for that remnant population of marbled murrelets. Should we be doing something about trying to get some sort of protected status, which really small areas, but potentially quite meaningful for the persistence of that population over time. Thankfully, we do have that complex of wildlife refuge islands, national wildlife refuge islands, and that includes nearly all of the former and current tufted puffin colonies. So in terms of protection of these important seabird breeding islands in Washington, we're actually doing really well. We're incredibly fortunate that way. We are working with state and federal partners to try to do some habitat restoration on some of the degraded islands. So that's early on, but it holds promise. We really need to get a better handle on forage fish populations. And that's starting to become a little bit more visible at the state level. but we need people to keep reminding our legislators, this matters. This is really fundamentally important to the health of our marine waters. And then I just want to conclude with community-centered conservation. You know, it's ultimately, conservation is about people. Like, we can study things to death, but it's the actions that we collectively choose to do and the actions we choose not to do which are going to move the needle. So you coming out today, getting involved in community science, helping out, raising awareness, whatever works for you, everything matters, even small things, even going away and talking to someone about tufted puffins, you know, that matters. You never know where those sorts of ripples carry out. So there are some wonderful opportunities to get involved formally. There's the marine resource committees, you know, that are an amazing resource here in the state. That they're all volunteer driven. And then again, these community science programs. So please do think about, you know, how you can get involved, whatever that looks like for you, because the science alone is insufficient, and that has never been clearer to me than it is, you know, it is now. So with that, I want to thank you.